Let's talk about rectangles. A rectangle is a parallelogram with 4 congruent angles. Notice again, similar to what we talked about with rhombuses, that this definition includes the fact that a rectangle is a parallelogram. So that means that all of the things that we learned about parallelograms in a previous video are also true for rectangles. So a rectangle has 2 pairs of opposite sides that are parallel, 2 pairs of opposite sides that are congruent, 2 pairs of opposite angles that are congruent, obviously they are because all 4 angles are congruent, angles that are supplementary to both of their consecutive angles, and diagonals that bisect each other, on top of the fact that it has 4 congruent or right angles. So that's a lot of information, and we actually have one extra bit of information to add on to that, and that's the fact that the diagonals of a rectangle are congruent to each other. Not only do they bisect each other, which is what we learned about parallelograms, but if it's a rectangle, then the diagonals are actually the exact same length. So all of the things that we know about parallelograms, plus the fact that they have 4 right angles, plus the fact that they have congruent diagonals, there's a lot to love about rectangles. So let's put this new knowledge to work. Which side is JK congruent to? It would have to be congruent to ML, and that's just the opposite sides of a parallelogram theorem. And which side is JK parallel to? Also ML, but that reason is the definition of a parallelogram. What about JL? JL is one of our diagonals, and since this is a rectangle, we know that the diagonals are congruent to each other, so JL would have to be congruent to KM. What about angle JML? That's one of the 4 angles of the rectangle, and we know by definition of rectangle that all 4 of the angles in this shape must be congruent to each other. And that's the definition of rectangle. Here's an interesting question for you though. Angle JMK. So this little angle down here, which angle is it congruent to? It's congruent to LKM, this little angle. And that's an old school reason, that's the alternate interior angles theorem. JM is parallel to KL by the definition of parallelogram, so if I treat KM like a transversal, then these 2 angles would have to be alternate interior angles because they're on opposite sides of the transversal and in between the 2 parallel lines. So don't forget about all that old school stuff. Just because we're learning about new quadrilateral business does not mean that all the parallel lines and vertical angles and linear pairs, all the things that we've been learning about all year, it doesn't mean that that goes away. It's still fair game. So JMK is congruent to LKM by the alternate interior angles theorem. Pretty cool. Speaking of old stuff, angle JNM is congruent to KNL because of vertical angles. These 2 angles are non-adjacent and formed by the intersection of 2 lines, and therefore must be congruent to each other because of the vertical angles congruence theorem. What is the measure of A and B and C and D? Well, since it's a rectangle, A must be equal to B, must be equal to C, must be equal to D. And because of the corollary to the polygon interior angles theorem, we know that if I add up all 4 of those, it would equal 360. So instead of A plus B plus C plus D, we could substitute A for all 3 of the other variables. So 4A equals 360, so A must be equal to 90 degrees. So anytime we say that a rectangle actually has 4 right angles instead of 4 congruent angles, this is the proof for that, of why, if all 4 angles are congruent, are they each equal to 90? It's because of this line of reasoning. So I won't make you do this every single time. I'll just let you memorize that the 4 angles of a rectangle must be right angles or 90-degree angles, because if they're all going to add up to 360 and they're all the same thing, then they have to be 90. But all 4 sides are not the same. Only the opposite sides are the same, so E would be 92 by the opposite sides of a parallelogram theorem, and F would be 51 for the same reason. For our next problem, we're given that one of the diagonals is equal to 12g minus 11, and the other diagonal is equal to 9g plus 10. And since this is a rectangle, I can set those 2 variable expressions equal to each other because the diagonals are equal to each other. So solve that, and I find out that G is 7 yards, and that's because of the diagonals of a rectangle theorem. And that's all you need to know about rectangles. In our next lesson, we're going to talk about squares, which is a combination of this lesson and the previous lesson, because squares are both rectangles and rhombuses.